Oh, baby, I like it. Hey, and welcome back to the channel, all of you DIY motion simulator platform enthusiasts. Okay, for any newbies that have tuned in, all right, and are watching this and wondering, well, what's this all about? What's happening is the current 3 degree of freedom motion simulator platform, Dr ADHD, 3 degree of freedom, or the 3.5, if you've done the spring heave modification. I'll include a link now in my description to these tutorials that I'm talking about. This is a conversion for anybody who has already built their 3 degree of freedom motion sim or their 3.5. These first two tutorials are what you need to do to cut your 3 elements, your base plate, your mid frame and your top frame, down to now match the new 4.5 degree of freedom motion sim specs. But to understand how to build all of these elements, which will not change other than the shortening, all of the previous Dr ADHD 3 degree or 3.5 degree of freedom motion sim platform build tutorials found on my channel are all current and valid. They won't change. With the new 4.5 degree of freedom motion sim, I'm not going through an entire series of how to build everything that's already built. Funny about that. It's already built. All we're doing is shortening it. We are adding a new surge axis to the mid frame, a new trolley rail system, and we will definitely be going through how to build that step by step. And in the first video, the one prior to this, I went through what you need to do to remove on your mid frame, your front motor mount bracket and your uni joint to get that prepped for the new surge axis. But to understand all of these elements of the build for the base plate, the mid frame and the top frame, you need to refer to all of the current and valid build tutorials for the 3 degree of freedom motion sim platform that are on my channel. Oh, we've forwarded into the future, peeps, and you can see the new surge axis trolley rail system rails welded on here to our piece of 100 by 50 mid frame we're about to cut off. Don't worry about this, guys. This is in the future. How to build the 4.5 degree of freedom motion sim coming very soon. But let's finish these conversion videos for any of you guys that have already got your 3 degree or 3.5 built and what you need to do to convert it to the 4.5. You'll need to cut where I'm about to cut in the video, guys. You will need to cut your mid frame from the very front of your mid frame. So where you've already removed your front engine mount in the first video, if you followed that, measure from the front of your mid frame, measure back 355 millimeters, get it exactly marked square, guys, around every part of that piece of mid frame and cut it nice and square. You'll cut that off. I'm going to scribe that in. I'll put my square on. I'm going to also mark the sides. Okay. So then we've got that cut going right around. And so it's nice and square. There's no angle on it. We don't want that. On a nice straight cut, so we can bevel this a little bit, put a little bit of a chamfer on that, so then when we bring it together we've got a nice V to get our weld into. Before I do begin the cutting, and an important thing to remind people, okay, now not everyone may know about this if you haven't done a lot of this sort of work. Similar to using a chainsaw and cutting trees, okay, you have compression and you have release. You have energy in all of these items that you are cutting. Now we've got a frame here that is basically intact. So it means that there's going to be compression in some areas where we cut, and there may be release in other areas we cut. This can be dangerous because it can cause your disc while you're cutting to jam, grab, throw back at you. You've got to be really careful of these sorts of things. You need to get a bit of an idea from where the fulcrums are on the frame, whether it's going to basically compress in when you cut it or whether it's going to come up and spring. In this particular instance where we are with this, especially in the top, there is going to be some compression. So you just got to be aware of that. Compression means biting into the disc when you're using it, and possibly you losing control of the angle grinder. If it's a powerful angle grinder, this one's got a fair bit of grunt, that can physically cause my angle grinder to sort of jump back at me, move towards me, or pull away from me. And those things you need to consider, and you need to be careful when you're cutting that you don't end up pulling the angle grinder into your leg or something like that if your legs are close to where you're cutting, or any part of your body, or you indeed getting pulled away, losing balance, falling on the angle grinder while it's running, and those sorts of possibilities, guys. And they are possibilities if you're unaware and those things catch you by surprise. So you need to be careful with this. You need to have a look at your piece that you're about to cut, and you need to make those sorts of judgments. Is this going to be a compression cut? Is this going to be a release cut? Is something going to spring off when I've cut this and hit me? Those sorts of things you need to evaluate before you begin to do the work. This is dangerous work. You do this at your risk, but I'm trying to give you a heads up on the things that you need to watch out for when you are doing this type of work. So what I'm going to do from here, guys, I'm going to pack this side now, so then I can just follow right through to do the bottom side, but I'll pack this. Otherwise what will happen is that'll just drop down and it'll pinch the blade. So I've got what would be essentially the compression side. I've got it packed. And we have separation. So the principle will be the same for the bottom plate and the top frame when we cut this off. You will cut off your bottom plate after the stabilizer section. It's pretty much in the same location, but I'll give you an exact measurement. From the very front of your bottom plate stabilizer, you will measure back 240 millimeters. Make a mark, put your square on, and then cut your bottom plate off at 240 millimeters. You'll now have your separate section of the front part of your mid frame, which is welded on to your pivot caster, and that will come away with your bottom plate where we've just cut that. Let's just get this bottom plate cut. So I've got the bottom plate packed, so it's up off the ground. So it's actually in spring mode, guys. So it's in release mode because the weight is actually pulling down towards where the weight is with the mid frame on our front stabilizer setting here. But it will have a little bit of spring in it. And as you can see, with it being packed, there's spring in that. So there's energy in this, okay? You need to keep that in mind. As I said before, with everything that you're doing when you're cutting metals. Okay, there we go. Okay guys, starting with the bottom plate. Then where you've just cut your bottom plate off, to separate it, grab your tape measure, measure along 400 millimeters. Okay, we're taking 400 millimeters out of our bottom plate. Measure 400 millimeters, mark your bottom plate, put your square on, draw a line guys, and then with your angle grinder, cut that off and remove that 400 millimeters of bottom plate. Okay guys, we're going to do exactly the same thing with our mid frame now as we've just done with our bottom plate. The measurement is slightly different, okay? Because we remove 425 millimeters from our mid frame. Now this will become apparent while we remove this much material in the coming videos, so don't worry about that. All you need to worry about, if you're converting your 3 degree of freedom motion sim and you want to convert it shorter to the 4.5 degree of freedom, you need to take 425 millimeters of material out, right? So mark it at the 425 millimeter mark, okay? Put your square on. Rightio, hold it nice and steady, and with a scribe, a sharp pencil or a very fine Sharpie, mark it at that point. Now, do not attempt to just cut from that mark a straight cut. You will never cut through box straight if you try and go through a whole piece of box on one face. Turn your box around, okay? And for every face of your box, doesn't matter what it is, this goes for every single cut you will do going forward, for everything you'll build. Anytime you're using box, you need to measure every face the same. 425 millimeters, make a mark, put your square on, and repeat that for every side. If you've got a drop saw, you're okay. You can just mark one side. Your drop saw should keep a square cut. If you've got a horizontal bandsaw, okay, one mark is okay. Your saw should cut through that straight. But if you're using an angle grinder with a cut-off disc, which I assume most folks watching this video are going to possess, then this is the way to mark pieces of box to get a completely square cut with an angle grinder. And we've got bits of the Dr ADHD 4.5 degree of freedom motion sim all over the shop at the moment. Soon to be all brought back together with the new surge axis. Let's keep forging ahead, guys. Let's move to our top frame. Okay, your top frame, we've got to shorten this as well, obviously. So, guys, first thing to do is to remove the front motor mount push rod, pull rod bracket assembly that was on the front of the top frame. Take that off, okay? We're going to be doing some upgrades to the top frame as well as shortening it. With its new stouter version, it's probably going to come under sort of more forces, more stresses. So we probably need to just strengthen a few things up to make sure that it's going to be able to cope with those new forces that are going to be placed on it. We are going to completely rebalance our uni joint to our mid frame anyway, and I'm going to build in a movable uni joint setup for our top frame. The uni joint will move obviously anyway with the new surge axis, but we'll also be able to make where it's connected to our top frame, that will also be movable. So then we can get the balance right on the top frame. It's very tricky getting that balance right, and because of the much shorter profile that we have now with our new motion sim, it means that our motors potentially are going to come under a lot more stress, because the weight, which was once quite a ways away from those front motors, is suddenly coming a lot closer to our motors. So it's critical that we are able to move our uni joint to compensate, basically, to move it a lot further forward, so then our weight and our peripherals are behind the uni joint, so it balances the rig. And I think the best way to be able to achieve that is going to be make a system so then the main cross bracing on our top frame that our uni joint connects to can be moved along with the uni joint. Then we can place it exactly where we need it and get exactly the balance we need. So there'll be that conversion to the top frame. I'm also going to add another piece of 20 by 20. This is 20 by 20 box here on the 30 by 30. I'm going to add a cross piece in here also to give that front motor mount a little bit more bracing on the bottom, because otherwise it's only really braced on the bottom of that with two tech screws. So I'm going to add another piece that's going across here. Okay, conversionists, what you're going to do is from the very front of your top frame, the measurement you need to measure and cut is 460 millimeters. 460 millimeters with a very sharp scribe, a sharp pencil or a Sharpie, and I mean a Sharpie, you will mark in 460 millimeters inboard. on your top frame from the front of your top frame. But where we're going to cut this off, guys, to make that measurement valid and correct, is we're going to cut through here. So we're not going to come around and cut. We're not going to cut it off here. We're going to cut it off there. Okay, so then basically that slides in, if you like. Try to find a proper position here. So we're going to cut through here where you've welded your 2 metre lengths onto your 500 cross. Cut through there, guys. So literally that will slide back in, but we are removing this, but it'll slide down and become the new location. This front here will line up with where you've cut that 460 millimetres. Okay, now we need to be careful here with this last little bit that's hanging on, because there's going to be some spring, there's going to be some energy in this, so we need to be prepared for that. So of course, guys, when I cut through that, it closed, okay, and grabbed the disc. That's what you've got to look out for. Them's the brakes. All right, we'll cut the other side off, and then I'll show you where this gets welded back on. So once you've cut that off the front, this is how I've cut it, guys. I've cut it on the inside, rightio, and then I've basically slid that in. It's just sitting there in situ at the moment. The tension of the side rails with all the other cross bracing, etc., on the top frame is holding that in place, and you'll need to place the front of it level with your 460 millimetres. That's how it'll get welded. Don't weld it with this on the line. Weld it with the face or the front at the 460 millimetre mark. But obviously we'll cut this surplus length off now. We'll cut our 460 millimetres off, and then this will get welded back on at the front like I've just shown. Oh, look at this. More surplus metals for more projects. So as mentioned, guys, I'm going to bolster up this front motor mount timber bracket holder on the front before I re-weld this into position. I've added a cross brace here. If you remember from our video of how to set this up in the top frame tutorials, we've only got two 25 by 25s running vertically. Well, I'm going to put a horizontal piece in at the bottom, which will also be able to pick up 4 techs, and it'll just reinforce the bottom section of our Merbau timber bracket and just add more strength to that bracket. It'll just add strength, reduce flex, and the possibility of that Merbau splitting. So you'll just measure the distance between the 2 vertical pieces, cut a piece of 25 by 25 to match them, and then just place it on top, flush each end like this, clamp it, and the usual routine, guys. Make sure everything's clean to take your nice weld. Don't want any primer or paint or rust pollutants in the whirlpool. So just, tack each corner, and then you can run some beads right around and do the same for both sides. Rinse and repeat, guys. Just take the primer off, that's all we're doing. You don't want to remove metal, just the primer. One of the best ways to do that, guys, is the flap disc, because it's not as aggressive as a traditional grinding disc. Okay, we've got that back clean. Can I please remind you that when you put this back in, and don't worry, because the doctor has done these sorts of things himself. That's why I'm telling you not to do it, because it will save you a lot of swearing and time. Make sure when you weld this back in, guys, that you weld it with your holes for where your tech screws go when you place your motor mount Merbow timber bracket back on, that it's located correctly. Okay, so you'll get it back in like so. I'm going to clamp this. Obviously, we need it to be straight. We'll get a square on it in a second before we weld it. So you'll get it back in place like this, guys. I'm going to clamp it with my big clamp to hold it in position, and then I'm going to put my square on everything along the front, along the top, and make sure it's squared. Then I'm going to weld it in. So you'll just take your time with this bit, guys. Grab a square, grab your hammer, and like in the top frame tutorials for the 3 degree of freedom, we're basically just repeating that if you're needing to fine tune this. So I've got a clamp on, which is basically holding it in position. Now I'm just going to, with a hammer, manipulate this exactly where it needs to be. We all need a little bit of manipulation every now and then. Otherwise, why would we need a government? There's the doctor going off on an anti-government tangent. What would we do without governments, actually? Now, the problem with governments are they're full of people. So once you've got it all lined up, tacked in, guys, then just go around and weld it all in. And then you're done with shortening your top frame. Okay, guys, so for all of you peeps who had already built the 3 degree of freedom motion sim or the 3.5, that's the end of part 2, guys, of what you need to do to modify your rig if you want to bring it into the same spec as the 4.5. That's if you want to shorten it. You don't need to shorten it if you're okay for space. But if you want to add the new 4th axis, guys, the surge axis, you will need to carry out those modifications in tutorial part 1 of the conversion, where you need to remove that uni joint and that front motor mount bracket, ready for the new rail trolley system to carry our top frame to add the surge axis. So for everybody else who's champing at the bit, guys, for the new Dr ADHD 4.5, and I'm calling it the 4.5, guys, because we have the spring eve axis, and I'm counting that, guys, as half a degree of freedom, okay? That's why it's a 4.5. I'll probably label it as a 4 degree of freedom, guys, in the videos, because that's what YouTube is more likely, and its algorithms are more likely to help my video promote, because there aren't really any such thing as a 4.5. So it is really a 4 degree of freedom motion sim going forward. With that spring heave, it sort of just adds what I reckon is about half a degree of freedom. So for everybody that's champing at the bit to get a bite and have a crack at the new Dr ADHD 4.5 degree of freedom motion sim, it's going to be a few weeks away, guys. I've got to put the whole rig back together now. I've got to build in the new trolleyage carry system that's going to carry the top frame to allow the new surge axis, and everything's got to be painted. You will see the rig in all its glory, guys, in a really good demo of working with flight sims and with car sims before we start the tutorials. Then we'll begin the tutorials, guys, for how to build it with all the new specs. So this will include all new measurements for the new dimensions required, because obviously this is going to change the amount of materials that you're going to require to build this. Everything's a little bit smaller, so you're not going to need as many materials as were in the original very first materials needed video that I released on building this 3 degree of freedom motion sim, now the 4.5. So I'm going to include a complete list of what you need to purchase now to build this. Most stuff is going to be the same, it's just going to change in how much you're actually going to need. So guys, I'll be back in a few weeks. Until then, I'll release a few little videos that I've already got on the back burner, guys, scheduled to release, just on how to mod IL2 Stamovic, a few things like that, guys, just to keep the wheels turning while I'm away getting this all sorted out and built, so then we can come back, guys, and have a new 4.5 degree of freedom motion sim. How exciting is that? So until then, guys, you guys stay safe, stay healthy. take it easier.